did on Wednesday of week 8, just before Thanksgiving. We did that great problem, the ballistic pendulum. And so we have, say, a block hanging from ropes, and the rock has mass big M. And we send, say, a little bullet with some speed we'd like to know, v, and it has some little mass m, into the block. And then afterwards, the block has risen up with the bullet in it, and we're given some angle theta, and we know that the length of the ropes is L. Okay, and the question is to find, whoops, hold on. Okay, I'm back. So, let's see. What was I doing? Yes. So, find the velocity of the bullet. Now, the tricky thing about this problem, and this is called the ballistic pendulum, the tricky thing about this problem is that this is actually two separate problems. Implied here is a middle frame to this movie when the block has the bullet embedded in it and it's taking off with some new speed. And so the first part of the problem is an inelastic collision problem, and so we use conservation of momentum. So part 1 is that m times the velocity of the bullet is equal to little m plus capital M, the block, and their new speed that they leave together. So that means that v new is m over the total mass times v. Okay, now that we have v new, now part 2 is conservation of energy, conservation of kinetic plus gravitational potential. Okay, so we have, let's see, where are we? So, okay, so beforehand, oh boy, so now we'll have to define a 0 point for the potential energy. So let's say, oh gosh, let's say I'm going to pick at the top here, this is going to be y equals 0. Remember, it has to be positive going up, but that's not going to be a problem. So right just after the collision, it's 1/2 m plus m v new squared plus, okay, the gravitational potential energy now is going to be mgy. It has to be negative because if I set y equals 0 at the top, it's positive going upward, so it starts down here when it's negative. So negative mgl, because the length of the ropes is L. Okay, that's before, and then afterwards, it swings up to a maximum angle theta, which means the velocity of the two together, maybe v prime we'll call that, is 0. So that means it has no kinetic energy, but it does have, oh, whoops, here's a mistake here, isn't it? This is supposed to be little m plus big M. There we go. Because then at the end, we're going to have m plus m g, and it's still going to be negative, but now we have to figure out their new height. And remember, it's just this part right here. It's just the y component of the height. So that's going to be L cosine theta. Okay, and so what is I trying to find? Oh yeah, so the velocity, and so I know that 1/2 m plus m, so now I take both of these two together, times v new, so m over m plus m v squared minus m plus m gl is equal to minus m plus m gl cosine theta. So, okay, let's see. Oh, well, I can cross out the m plus m's here. That'll make things a little bit easier. And I'll multiply through by 2. So that will be m all over m plus mv squared minus 2gl is equal to minus 2gl cosine theta, and I'm solving for v. Okay, so I get that v squared is equal to m plus m over n squared. I'm going to bring that to the other side, and I'm going to do times 2gl 1 minus cosine theta. So the velocity is m plus m over m square root of 2gl 1 minus cosine theta. So you can measure theta, you can measure L, you can measure the masses, and that allows you to actually calculate the muzzle velocity. I think this is a pretty cool problem.